Okay. Morning, everyone. And go share screen and make a present about parking design. I have noticed that many of you have some difficulty in cars. So this presentation is on importance regarding parking design. Now we have to consider that there are different types of cars with different widths and lengths. We have standard car, which is about 5 meters long by about 180, and it requires an area of about 2.5 by 5 meters for parking. For four-wheel cars, luxury cars, it usually requires 3 by 6 for enough parking. An important point that we have to consider is the and it can cause problems for the cars during the entrance and the exit and the entrance to the ramp. So usually we provide less slope in the beginning and end, and then the ramp is 12%. We usually use the 10% ramp slope was convenient for the car. 12% is difficult for the users to really use the car. The next slide. Here we deal with the ramp with the radius required for the car turn. Cars need enough radius to turn. They cannot turn in their place. So the radius, the minimum radius for the wheels would be 6 meters or 5.7 or 6 meters. This is also barely enough for the car to turn. It depends on the direction that the car is going to. In order to have a complete radius, so we need about 6 meters or 6.28 outer radius of the turning, and the inner radius is 3.25 meters, 3.25. So we need to consider as radius develop the car ramp. So be careful when you design the ramp; it has enough radius for the car. Okay. The next slide here, it gives slopes for different ramps. If you're using it for pedestrian and cars, it's any maximum 8%. For cars, it would be difficult for people, 10 or 15%. As I said, we should not be 12.5 because the too steep for the car. Here we review different dimensions, standards. As I said, 180 to 5 or 2 by 5 for the car dimension. It requires one space for opening the doors and the for the car to open. We have to make sure that there is enough distance car ends so they don't hit each other, and there is also a distance between the car and wall, so and should be a protection, a rubber protection at the end. So the appropriate radius for the car wheel should be 5 to 6 meters, and for the car to be able to rotate easily and nice to its location. Here is also an example of if we want to have a large entrance and exit in the same ramp, it has to be clear and divided curve that. So this is another view of a ramp going in and out of garage. These are different arrangements for parking. This is parallel to the road parking, so the car will come in here and park. This is inclined parking, 30% oblique. It can be 45 degrees, which is more convenient for the car to park. And this is the standard parking that we all use. So if the car, it's a small size car, 5 meters and 5 meters, we also need about at least the same dimension of the car for the car to be able to rotate and enter the parking spot. So these are some dimensions. We usually use 6 meters, so that makes the parking easier. These are different types of dimensions of car parking, and according to the standard of 6, 30, 45, 90 degrees parking and so forth. These are also other illustrations of car parking that you can review, parallel to the road or inclined or 45, 60. And this is the normal and new type of parking that we use, which is the type of perpendicular parking on sides. These are also other illustrations. You see, the parking is not only the area where we where we park the car. You will need area for greenery. You will need sidewalks for people to walk. So car parking usually requires a lot of space, because you need to add landscape, curbs for people to walk on, in and out, and so forth. So we need to have clear idea about that. Parking requires a lot of space, and we should provide enough space for that. This, as I said, the usual arrangement. We have 6 meters and 6 meters. And 5.5 is sufficient so that the car can enter and parking spot. So we usually place the columns every also a column here for the basement, which is every 3 cars. So 3. So this dimension will be 7.5, 8 to 9 meters. So you have to consider the location of the structural system when you design the car park. So it's again function and structure at the same time. Now we have here some requirements for the handicap. We have to provide parking for handicap, so it requires a large area for the wheelchairs to go out of the car. They keep the wheelchairs in the trunk, and then someone will bring the wheelchair. But we need to have enough space for the doors to open, if it's the driver or a passenger. So when we design handicap, we have to leave enough space for the doors to open completely and the person to go out of the easily. These are different types of parking structures that we can use as a ramp, and will be used as parking also. So we have parking on the ramp itself. So that space, and have, and this is the entrance of the parking, and then you can park on the ramp itself, and then there is a turning space for the cars go to the next level and so forth. And this is a double way, so that cars can go in and out from the same place. These are different examples of the ramps that can be used as parking. طبعا it can have different directions, and you can utilize space in an efficient way. These are different plans and isometrics to show you how the parking structures work. We have here the parking. The ramp is on the side, and it is leading to the interior of a parking structure. طبعا we have to make sure that the circulation inside the parking is clear, and that it has easy access to the places where we want to go. So if this is the ramp here, so we can go up and then go to the parking from here or from here, and we can go around and then go out from the other ramp. So this is a ramp that has one single direction. Here, as in this example, you see that the the ramp itself is used for parking. So the parking is on both sides, right and left. Also another example of a ramp up and down, and then parking is on the flat surfaces. In this case to the right, we have the spiral ramp. The spiral ramp is more complex, but it is used also in many parking structures. So you have the parking, and at the end there is a ramp going up or a ramp going down. So you can go up or down from the same ramp. It's very complicated, but it is used in many parking structures as well. Here are some examples of the different parking arrangements. So we have to provide a good station access, good ramps, so that we can have the ramp of the park. This is an example of the park ramps for a ramp. So 3 meters for each passage of the car, and then we go inside the parking structure and start to design the circulation inside the parking structure. This is a dimension of the car. So you have to provide 2.7 meters for the door, and then you need more space inside, about 3.56 meters to 4.5 meters, so that the car can open the door inside the garage. These are dimensions for the turning of the car, and the dimensions for the handicapped parking. As I said, you need to leave at least 4.3 meters on the sides so that people can go in and out the car. These are again different examples of car parking and bicycle parking. Also, if you have enough space, you can provide bicycles to encourage people to use bicycles. طبعا we try to design the parking so that the cars avoid hitting the a wall or an end of the park. This is a parking where you have the ramp in the middle of the garage, and then the cars go out, and then they can go down from the ramp here. So these are two ramps, one goes down. The circulation inside the garage is very important. In this case, we have a ramped car park. So this is a ramp, so people go down in the ramp, and then they can go to park right and left. As you see in the section, the parking is on the ramp itself. So that saves طبعا space, and it's convenient to use in buildings. This is an example of a car parking under a underground. So this is a large park, as you see, and it has entrances and exits from the outside, and there is of course circulation of how the cars will go and leave and then go to the exit. So this is an essential part of the garage. How will people enter the garage, and if there are tickets and stuff like that, and then they go in and use the garage for parking. And circulation should be clear. How will the cars go around? How will they move? And then how will they go out again to the exit of the garage? In our case, we have 3 exits. One, this is for emergency, so that you can evacuate the garage easily, quickly. And there are entrances, 2 entrances from here. And this part here is the ramp goes down. So you can go down from here. This garage is full, and you go out from here. Several floors. You have to provide ramps and ramps going up, and then they can go out from here or they can enter from here. So when they enter, they can go right to the garage itself, or if they are coming out from here, they can go out. This circulation is very important. As you, the garage is very simple. It's a straightforward design. You have road and entrance to the garage. You have columns. These are columns every 3 cars. Structural elements in your design. Every 3 cars we have columns. One, because we have a roof on top of this structure. This is another example. As we said, we have the spiral ramp in this side that also takes cars down and up, and cars can go easily to the. We have an entrance from this side. Here we have exit from this side. So if you have ticket, you have to pay for you. So the garage, the circulation like this. If you find parking here, okay, you can park, or you can go to park here, or you can continue and go around, and you can go in and out also from the secondary entry. If it's the garage, you need more than one entrance and exit. As you see here, we have one entrance here and another entrance, exit here, and we have another exit here. Okay, so this is very essential for your design to have more than one entrance and exit. Also, in this example, we have one entrance and exit here and one entrance and exit. Here we have a garage where we have the ramps going all around, and then you park. Here is another example. You have an entrance and an exit. You can enter the garage, then from here. This is an isometric show how the garage works. So in this example, we have parking garage that has an entrance in here. So this is an entrance, and the garage. Here show where the garage, the direction is, and the car park. So we can go around and park, go right and left, and move around. طبعا there are, of course, because you need ventilation. So there are ducts here that provide ventilation for the garage so that you can have a good air quality inside. So here we have also another entrance. The cars go in, park. So this is another isometric showing the entrance and the garage. And you see the columns are very clear here. The columns, every, so 3 cars here and columns. So this dimension would be like 9 by 6 meters, which is reasonable concrete plate size. So this will be 9 by 6 for between a column. It can be 9 by 9, 9 by that's a good size for the But notice the columns are clear and visible in the design. This is another isometric also illustrating the parking garage. This is a multi-story parking garage. This is a whole project, and I'll show here some projects to illustrate how this works. That entrances, exits, clear circulation, clear structural system. It's very important that the structural system is visible. You have columns, even if you have to enlarge them a little bit. But as we have columns, we have every 2 or 3 cars, and they can be created so that the structure can be divided into smaller plates. So this is an example of underground parking. We have entrances, as I said. When it's an underground parking garage, we need to on the end. Another example of a like the one in more exit in differences, so the cars can go under the shopping and go around easy. This is a small size, it's a nice illustration of what we should be having. As you see, we have a ramp going to the garage. They have only one entrance and exit because it's a small building. We have entry from here, and you have exit from the garage. You see the lines of curb to the commercial area, and this is entrance to the office lobby. And then it takes you to the elevators and staircase in the back. You see that is designed nicely, so read the easily. There is a drop off, there is a sidewalk, and escalator that takes you to the upper. So the plans should be clearly so people can read them and understand. This is the upper floor, offices, and the battery of elevators and staircases. So this is the building. As you see, the parking garage here is several floors low with the ramp that we have before. So this is the street level in this, and this is the street level in the other. So there is a difference in levels in this building. So we have a direction from here. So there is a cafe at this level, and also there is a commercial activities in these 2 levels. So this is it's an interesting example that shows the how can be if you have different levels. This is another example of a parking structure, as I said, on a ramp, so easily used and accessible by the people. This is how, if you need to make a picture outside your building, it's okay to accommodate a number of cars that is needed. طبعا the circulation, I don't want to repeat myself, but the circulation the entrance and exit of the garage is clear. The circulation to the lower levels, ramps going down and going up here again. So you can go up and go around. The circulation is clear. You cannot leave any spaces undefined in the garage. If you use it for cars, that's okay. If you don't have extra spaces that you have in the garage, you can use them for mechanical, for storage, for technical systems, and so forth. So this is an example of the garage. This is another example. Also, very clear system of circulation, entrance and exit. We have the entrance and exit here. We have the circulation is very clear. Cars park in their spots, then they go in, down and up level of the garage. So please, keep it simple, straightforward. No need for complications in the garage. These are some examples for you to look at. This is if you have spiral ramp at the end of the garage. So you can have different forms of the parking that you design. So these are some examples for you to look at, study on your own, and review the design of parking. This is how it looks from inside. As you see, we have columns, very clear, as we have 1, 2, 3 cars, and then a column. So this is the column, and this is the column. And this is a compact, so maybe this will be like 7.5 between the columns. We usually have 6 meters for the road. The typical of a garage. Some other examples. Everything is clear. You have one, of course, in the roof. You need to have lighting. Good lighting. We need to have ventilation for different levels because there is no air. So this is the structure. You have the columns. The structural columns are very clear. This is a typical you can see in different places, office buildings and stuff like that. So as you see, this is the entrance to the garage and exit, and this is how the direction of the cars. This is an example of outdoors parking garage. Surface parking, as you see, it requires areas for agree for passages, curbs, and stuff like that. When we do this surface parking, we have to make sure that we have good pavement and also good system for drainage of and this is an example landscape in the park and make it more. Nowadays, people instead of making the pavement, traditional pavement of black asphalt, they say, why don't we make cars? It will have good sunshine, and also it will look nice from the nice view of things around instead of black asphalt in the طبعا you can find many good ideas, especially sustainability. Instead of having just cars, we have solar panels as protection for the cars, and we can use the shades for the as solar collectors, generate energy. This is also another example. You can have part green, part solar, as you see here. These are different examples for you to study and look at. The entrance, you see it. Parking takes a lot of space and it needs full design. Thank you very much, and I find it useful for your park design.